Let us study the paper chromatography. Already I have told the paper chromatography is one of the separation technique. The mixture of the substance is mainly done on a specially designed chromatographic filter paper. Here I have shown this rectangular piece is considered as a specially designed chromatographic filter paper. Here, the stationary phase is water present in a cellulose. I already told one is the stationary phase and the second one is mobile phase. And here, the stationary phase is nothing but the water present in the cellulose of the filter paper, and the mobile phase is a organic solvent. Here, I have taken the organic solvent as a mobile phase. Then what is the principle behind the paper chromatography? The principle is the substance is distributed in two different liquids which are invisible with one another. Here the component of the mixture are separated, are migrated at different rates and appears as a spot at different points on the filter paper. Here, what is the principle here? The substance is distributed in two different liquids. Here, both the liquids are immiscible with one another, means they can't mix it with one another. In such cases, the components are from the mixture are separated, are migrated at different rates. Means the mixture that is present, I have taken here the mixture of the substance. Suppose this mixture contains A, B, C. These are the components. And these components are separated from one another. Then what happens? Suppose there is A is there, B is C. These three components are migrated at different rates over the filter paper, and they appears in the form of spots at the different points on the filter paper. Actually, they are separated like this one. And this type of separation is achieved by differential migration of the components. Means the components are moving over the stationary phase with the help of organic solvent. But the migration is quite a different one, and that can be achieved by differential migration of the components. Lower the value of partition coefficient, more will be the component will pass into the mobile phase. Here we know the partition coefficient. Depending upon the value of partition coefficient, lower the partition coefficient value, more will be the component will pass into the mobile phase and move at the higher speed. Here, all the three components A, B, C, they are migrated, but they have different rates. Depending upon the partition coefficient value, they are migrated and they appear in the form of spots over the filter paper. Now I have taken the one of the chromatographic filter paper, and this is one of the pencil line is drawn where the mixture of the components are appears on a pencil line in the form of spot or a drop is placed. At the same time, pure A, B, C, these are the three components are placed on the same pencil line separately or at different intervals, which are a pure form. Actually, this is the filter paper, and here the mixture is also placed and the reference substance is also placed on a chromatographic filter paper. In the procedure, draw a parallel line nearer to the edge of the rectangular piece of the filter paper. This is a rectangular piece of filter paper. Near at the bottom edge, I have drawn a pencil line where a mixture of substance is placed in the form of a drop. At the same time, the reference substance is A, B, C also placed. Then the mixture is separated is appeared in the form of a drop on a line. At the same time, the original pure substance is also placed at different intervals in the form of spots. And such type of filter paper is taken or placed hanging position in a box, and that box is made up of a glass one. Means in the glass, this chromatographic filter paper with this arrangement is allowed to hang vertically in a glass box. And at the bottom, there is a organic solvent is placed. Here at the bottom, there is an organic solvent is placed. Here it is observed that just this filter paper is touches the organic solvent. Clear that care should be taken, and the pencil line and these spots are to be appears very clear one. And such type of the filter paper is allowed to hang in a glass box, and the box is closed. Then what happens on closing? At the same time, the organic solvent is going to be vaporized. As you know, because of the organic solvent, the boiling point will be very less. What happens here? The organic solvent is vaporizes, and the vapors are comes in contact with the filter paper. The solvent vapors rises up by the capillary action. What happens? With the help of capillary action, you know the filter paper is there, and here the solvent is going to be vaporized. The vapors of the solvent are comes in contact with the filter paper, and with the help of capillary action, the solvent starts to move upwards. What happens when that solvent is comes in contact with a pure ABC substance as well as the mixture of the substance that is appears in the form of spot on a pencil line. Then what happens? The solvent comes in contact with the mixture as well as the pure ABC components. There, these components are mixes with the organic solvent or dissolves in the organic solvent, and they also starts to move because the solvent is going upwards with the help of capillary action. It is moving. At the same time, the pure ABC substance as well as the mixture of the components comes in contact with the solvent, and when the solvent is going upwards, at the same time these components are also move over the that is stationary phase, and they comes to an end at different points on the filter paper. Here, that is solvent comes in contact with the mixture of the substance. At the same time, they rises over the filter paper at different rates. Means ABC components are also starts to move at different rates, and the mixture of the component present in the mixture, they also starts to move at different rates and forms the spots on the filter paper. Finally, what happens? The solvent rises and they appears in the form of spots on the filter paper. After that, the filter paper is replaced off, it is dried, and the components are identified, and it is possible to separate these components by using the RF value. Here we have taken the help of RF value. Then how to calculate or how to know the RF value? Here RF value is nothing but a, here RF value can be calculated. Here RF means the RF value. RF is equal to the distance traveled by a pure substance. The distance traveled by a pure substance divided by the distance traveled by the solvent front. That is RF is equal to x upon y. Here x is the distance traveled by the pure substance and y is the distance covered by the solid center. Means here this distance is determined, these distances are determined, and on the basis of the distance traveled by the pure substance and the distance traveled by the pure solvent, that gives the RF value. And next point is you go for the calculation of RF value. Next one is calculation of RF value. How to calculate the RF value? We proceed to the next class. Thank you for your patience hearing.